All right, okay. So now we're at D of example 42. So we're continuing example 42 and we're at D. Now at D, we're asked to find the points for which d2y by dx squared is equal to 0, and we're to classify the points. Now, what we have done so far is that we have determined the values of x for which d2y by dx squared is equal to 0. And the values of x are x is equal to 1 plus the root of 7 over 3, which is approximately 1.2. And the x is equal to 1 minus the root of 7 over 3, which is approximately minus 0.5. d2y by dx squared is equal to 3x squared minus 24x minus 24. All right. So now that we have the values of x for which d2y by dx squared is equal to 0, now we need to determine the values of y. So to do that, I'm going to say when x is equal to 1 plus the root of 7 over 3, y would be equal to 3 into 1 plus the root of 7 over 3 to the 4th power minus 4 into 1 plus the root of 7 over 3 to the 3rd power minus 12 into 1 plus the root of 3. Sorry, that should be the root of 7. The root of 7 over 3 square plus 8. And when we work that out, what we're going to end up with is, and to work that out, all you have to simply do is put this into your calculator and just press equal. When you work it out, what we end up with is minus 10.4. So 1.2 minus 10.4 is a point on the curve where d2y by dx squared is equal to 0. So next I'm going to say when x is equal to 1 minus the root of 7 over 3, y would be equal to 3 into 1 plus, sorry, it should be minus the root of 7 over 3 to the 4th power minus 4 into 1 minus the root of 7 over 3 to the 3rd power minus 12 into 1 minus the root of 7 over 3 squared plus 8. And if we put that in the calculator, we're going to get this is equal to approximately 5.3. So, and remember that this was already minus 0.5. So minus 0.5, 5.3 is another point in the graph where d2y by dx squared is equal to 0. And of course, the next thing we're asked to do is that we're asked to classify these points. So to classify these points, we're going to use the second derivative test. We already found the second derivative, and d2y by dx squared. So we actually have it up there. So we could write it again. We'll just find somewhere to, d2y by dx squared, which is equal to 36 x squared minus 24x minus 24. Now, to test the points, I'm going to say when or before the point to determine if it's a point of inflection. at the point of inflection, d2y by dx squared is equal to 0. But if d2y by dx at a point where d on the curve where d2y by dx squared is equal to 0, it is not necessarily a point of inflection. So you have to test it in order to determine if it's a point of inflection. So what we're going to do is that we're going to check the concavity before the point and the concavity after the point. Now, if it changes, if the graph changes concavity at that point, we would then know that that point is a point of inflection. So what I'm going to do is I'm going to say when x is equal to 1 plus the root of 7 over 3, which is approximately 1.2. I'm going to say before this point, before x is equal to 1.2, let us say maybe when x is equal to 1, d2y by dx squared would be equal to 36 times 1 squared minus 24 times 1 minus 24. All right, and that's going to come out to be negative because it's going to be 36 minus 48, which would make d2y by dx squared negative. So d2y, so when x is equal to 1, d2y by dx squared is less than 0. All right, so if it's less than 0, means that it's concaving down. Before x is equal to 1.2, the graph is concaving down. Now, after x is equal to 1.2, for example, when x is equal to 2, d2y by dx squared, d2y by dx squared was greater than 0. So this was already done. We did this earlier when we were testing, when we were trying to determine the, when we were trying to classify the turning points. So this was done earlier. So you can notice before x is equal to 1.2 and after x is equal to 1.2, the graph changes concavity. So therefore, the point 1.2 minus 10.4 is a point of inflection. All right, so we can also look at before x is equal to minus 0.5. For example, like when x is equal to minus 1, d2y by dx squared, this was already done, was greater than 0. Again, this was done when we were trying to classify the turning points. And after x is equal to minus 0.5, for example, when x is equal to 0, d2y by dx squared was less than 0. This is already done. So again, before and after, before x is equal to minus 0.5 and after the graph change concavity, so therefore minus 0.5, 5.3 is a point of inflection. All right, so we know the turning points and we know the points of inflection. Essentially, we should know enough now to sketch our curve. So this is the information we have gathered so far. And of course, the curve we're trying to sketch is y is equal to 3x to the fourth minus 4x cubed minus 12x plus 8. So let's put in our points. Minus 1, 3 is a minimum turning point. So minus 1, 3, which is here. We have a minimum turning point. At minus a half, 5.3, we have a point of inflection. So minus a half, 5, 5.3 would probably put me around here. Minus a half, 5.3. That's a point of inflection. 0, 8 is a maximum turning point. 1.2 minus 10, 1.2 minus 10.4, 1.2 minus 10.4, so 1.2 put me here, 10 point, this is 11, 10.4, minus 1.2, 10.4 might drop me somewhere around there. And the final point is 2 minus 24. 2 minus 24 is all the way down here. And 2 minus 24 will put me here. All right, and 2 minus 24 is a minimum turning point. So with that information, let's try and see if we can draw a graph. So let's start off with the only maximum turning point, which is 0, 8. All right, so I have a minimum and then a maximum turning point. All right, now from up here, let's go down to our point of inflection. From the point of inflection, let's go to our minimum turning point. Turn, and then let's go try and go back up a bit. We don't have to go all the way up. All right, so we're going up, going up. All right, and of course, this would be our sketch of the curve. Y is equal to 3x to the fourth minus 4x cubed minus 12x squared plus 8. And to sketch this, we obtain the maximum turning point, the 2 minimum turning points, and the 2 points of inflection. We plot them on our graph and sketch our curve, sketch our polynomial, which is a smooth curve, smooth unbroken curve. And from top to bottom, this is our curve. This is what we're asked to do. And so this example is finished.